Hello friends, myself Dr. Nandakumar Rao from College of Engineering Ambazugai is going to deal with numerical methods in mechanical engineering. This is our 10th lecture. In previous lecture we have discussed about Cramer's rule and the numerical on a Cramer's rule. Now today we are going to discuss Gauss elimination method to solve algebraic equation. So yesterday one of the student has asked the question that what is a variable and what is unknown. So for example, we have one function f of x is equal to x square plus 2x plus 3. So this x is known as a variable, or it is known as an independent variable. Independent variable, and f of x is function. So if value of x is changed, say for example x value is 0, then function value f of x is going to be 3. If x value is changed to 1, then function value f of x is equal to 6. That means this value of x can vary. It is not going to be constant with respect to value of x. The function value f of x is going to change. So this x is known as an independent variable and f of x is known as a dependent variable. Dependent variable. So this is what about variable. Then what is an unknown? So for example, we have two simultaneous equations, x plus y is equal to 3, 2x plus y is equal to 7, say. So if we find out the value of x and value of y from these two equations, then these values of x and y are not going to change with respect to equation number 1 and equation number 2. The values of x and y are going to be fixed, but right now those two values of x and y are unknown, which satisfy the conditions or equation 1 and equation 2. The values of x and y which satisfy equation 1 and equation 2 are known as unknowns, whereas the value of x which is independent variable, or by substituting value of x we get function value f of x. So here this value of x is known as a variable, but the value of x and y in these two simultaneous equations are known as unknowns. Okay, now we will proceed about Gauss elimination method. What this Gauss elimination method is and how it is different from Cramer's rule. So these two methods, Cramer's rule or Gauss elimination method, are used to solve simultaneous algebraic equations to find out the values of unknown. Now, say for example, a11 x1 plus of a12 x2 plus of a13 x3 is equal to C1. This is one algebraic equation with three unknowns x1, x2, x3. Then we take another equation, algebraic equation a21 x1 plus a22 x2 plus a23 x3 is equal to C2. So this is equation number 2. Then a31 x1 plus a32 x2 plus a33 x3 is third equation. These are the three algebraic equations. Now these three algebraic equations are solved in such a way that the upper triangle, it is reduced to upper triangle in the sense if we take its coefficients, that is a11 a12 a13 a21 a22 a23 a31 a32 a33. So this is reduced to the upper triangle in the sense So the values in the lower below the diagonal are reduced to 0. So these constants are reduced to 0 by making the row operations or column operations, and then this determinant of this can be obtained, and from that we can find out the value of one of the variable, that is x3. So value of variable x3 can be obtained, and by taking a reverse path we can find out value of x2 and value of x3. So that is nothing but the main method used in Gauss elimination method. So the lower it is reduced to the upper triangle. The elements of lower triangle are brought to the 0. So how it is brought to the 0, that we see. So this second equation is multiplied by a11 and divided by a21. So it is multiplied by a21, a21 it is multiplied by, sorry, first equation is multiplied by a21 and divided by a11. So multiplying equation equation 2, sorry, equation number 1 by a21 and dividing by a11, we get one new equation, say a11 x1 plus of a12 x2 plus of a13 x3 is equal to c1, and this is multiplied by a21 divided by a11. So a11 gets cancelled, so we get a21 x1 plus of a21 into a12 divided by a11 x2 plus of a21 into a13 divided by a11 x3, which is equal to a21 into c1 divided by a11. So say this is equation number 4. Now we are going to subtract this equation from equation number 2. So subtracting equation 4 from equation number 2, we get, so equation number 4 is subtracted from equation number 2, then we get as here the variable x1, so unknown x1, so a21 minus a21, so these two gets cancelled. So subtracting this equation number 4, that is multiplying this by minus, minus, minus and minus. So if we subtract this term from first term of second equation, so this becomes 0. Then if we subtract this term from a22, we get a22 minus a21 into a12 divided by a11 into x2, then plus of a23 minus of a21 into a13 divided by a11 x3, which is equal to c2 minus of a21 c1 divided by a11. So this is equation number 5. So we get equation number 5. Now this equation can be rewritten. Say for example, this bracket we take as a dash 22, means a dash 22 is this complete bracket, into x2 plus of, we can take this second value as a dash 23 x3, which is equal to c dash 2. So this term is taken as c dash 2. So that is nothing but a dash 22 is taken as a22 minus of a21 a12 divided by a11. Then a dash 23 is taken as again a23 minus of a21 into a13 divided by a11, and c dash 2 is taken as c2 minus a21 c1 divided by a11. So these are the three things which we have substituted and from which we got this equation number 6. Then again multiplying this equation number 1 by this coefficient a31 and dividing it by a11 and subtracting it from equation number 3, we get, so here once again we write equations a11 x1 plus of a12 x2 plus of a13 x3 is equal to c1. So this was equation number 1. a21 x1 plus of a22 x2 plus of a23 x3, which is equal to c2. Equation number 2, a31 x1 plus of a32 x2 plus of a33 x3, which is equal to c3, equation number 3. So now multiplying this equation number 1 by a31 and dividing it by a11, we get it as a11 x1 plus of a12 x2 plus of a13 x3, which is equal to c1, multiplying it by a31 divided by a11, we get a11 gets cancelled, we get a31 x1 plus of a31 into a12 divided by a11 x2 plus of a31 into a13 divided by a11, which is equal to a31 divided by a11 into c1. We call this as equation number 7. Now this equation number 7 we are subtracting from equation number 3. Equation 7 from equation 3 we get, so multiplying this by minus and subtracting from equation number 3. So a31 gets cancelled, so this term, first term becomes 0, and second term a32 minus of a32 minus of a31 into a12 divided by a11 into x2 plus of a33 minus this term a31 into a13 divided by a11, which is equal to c3 minus of A31 divided by A11 into C1. So we can call this as equation number 8. So in this equation number 8, we can replace this first bracket as A32 dash x2. So this bracket is replaced by A dash 32 x2 plus of A dash 33 x3. So here x3 is to be written x3, which is equal to C dash 3. That is nothing but here we can say A dash 32 is equal to A32 minus of A31 A12 divided by A11. Then A dash 33 is equal to A33 minus of A31 A13 divided by A11, and C dash 3 is nothing but C3 minus of A31 divided by A11 into C1. Now from this we obtained equation number 9. So again we write equation number 1, equation number 6 which we have obtained, and equation number 9. So we write first equation A11 x1 plus A12 x2 plus A13 x3, which is equal to C1. This is equation number 1. Then let us collect this equation number 6 and we write this equation number 6. So equation number 6 is A dash, this term is not there, A dash 22x2 plus A dash 23x3, which is equal to C dash 2, equation number 6. So if you see here, A dash 22x2, A dash 23x3, C2 dash. Then again coming to equation number 9, A dash 32 x2 A dash 33 x3 is equal to C dash 3. So A dash 23 x2 plus of A dash 33 x3, which is equal to C dash 3, equation number 9. So now you can see here this term x1 is missing, x1 is missing. Now our aim is to reduce this term to 0. So in order to reduce it to 0, what we do here, we are going to multiply this in this way. So what we did here, multiplying equation 1, original equation, by coefficient of this and subtracting this from equation 3. So we have subtracted it from equation number 3. So original equation is multiplied by coefficient of equation number 3. So here also we are going to multiply this equation number 6. Equation number 6 by A dash 23 and dividing it by A dash 22, we get equation number 6 is multiplied A dash 22 x2 plus of A dash 23 x3, which is equal to C dash 2, and this is multiplied by A dash 23 divided by A dash 22. Then we get a dash 2 to a dash 2 to gets cancelled. We will get here a dash 2 3 x2 plus of a dash this was a dash 2 3. Okay, 1 2 a dash 2 2. Let me see 2 1 2 2 2 3 1 3 2. So this is 3 2 a dash 3 2. Just see here a dash 3 2. So multiplying this by a dash 3 2 a dash 3 2, just a minute. So this is a dash 3 2. If we see equation number 9, it is a dash 3 2 a dash 3 3 a dash 3 2 a dash 3 3. So multiplying this equation number 6 by a dash 3 2 and dividing it by a dash 2 2. So a dash 3 2 divided by a dash 2 2. So a dash 2 2 a dash 2 2 gets cancelled. So what is going to remain here is a dash 3 2 x2 plus of a dash 3 2 into a dash 2 3 divided by a dash 2 2 into x3, which is equal to a dash 3 2 into c dash 2 divided by a dash 2 2. So this is equation number 10. So this equation number 10 is subtracted from equation number 9. Equation number 10 from equation number 9, we get, so when we subtract means we are multiplying it by minus. So this, when is subtracted from first term, this term gets cancelled. So now what is going to remain is a dash 3 3 minus of a dash 3 2 a dash 2 3 divided by a dash 2 2 x3, which is equal to c dash 3 minus a dash 3 2 c dash 2 divided by a dash 2 2. So this equation can be written again as, so this is a double dash 3 3 x3. So this bracket is replaced, complete bracket is replaced by a double dash 3 3 x2, which is equal to c double dash 3, and then we call this as equation number 11, where a double dash 3 3 is nothing but a dash 3 3 minus of a dash 3 2 a 2 3 dash divided by a dash 2 2, and c double dash 3 is equal to c dash 3 minus of a dash 32 c2 dash divided by a dash 22. So this is 11 equation. Now once again we write equations. First equation, a11 x1 plus of a12 x2 plus of a13 x3, which is equal to c1. This is equation number 1. So now coming back here, equation number 6, a dash 22 x2 plus of a dash 23 x3, which is equal to c dash 2. So this is equation number 6. So this is equation number 6. Then equation number 11 is a double dash 33 x3, which is equal to c double dash 3. This is equation number 11. So now if we write these coefficients of these equations, a11, a12, a13, 0, a dash 22, a dash 23, 0, 0, a double dash 33. So this is the main matrix where it is reduced to the upper triangle. So the values of lower triangle are 0. So here first of all what we get is, so this was forward process which we have used. So now from equation number 11 we get x3 is equal to c double dash 3 divided by a double dash 33. So once we get x3 from this equation number 12 or this constant value, so this value of x3 is substituted in equation number 2, sorry, equation number 6, then we get value of x2. So then value of x2, x3 is known. So these two values of x2 and x3 are substituted in equation 1 to get value of x1. So we are going to get x2 and then we are going to get value of x1. So this is the reverse process in which we are going to get the exact values of unknown in the reverse process. Now let us see one numerical to simplify this, and with the help of a numerical it will be clear for us to find out the unknown values of unknown. So in next class we will be looking at this numerical. So for today this much is sufficient. So this is how we are using Gauss elimination method to find out the unknowns of algebraic equations using Gauss elimination method. So here we are going to eliminate lower triangle, therefore we call it as a elimination, Gauss elimination method. Thank you.